All right. The purpose of this screencast is to show you how to get 4 general kinematics equations, that's what they're called, to be used only for objects that move with constant acceleration. So, in other words, I'm going to take your data results and we're going to get 4 beautiful general equations for constant acceleration. These are called kinematics equations. All right, let's start. I got a sample set of the lab group's data here. And the first thing we're going to do is just say, well, what does this number mean? Right here. And if we break it up, we have, let's just call it 60. We got about 60 centimeters per second divided by 1 second. Okay? And then what does this mean? This means every second the velocity is changing by positive 60 centimeters per second. It would be possible to have a graph with a negative slope. It would be the same thing, except this would be sloped down and that would be a negative. But in this case, we got a positive slope on our velocity time graph. So we have a positive change in velocity that's happening each second. And so this is a change in velocity divided by a change in time. And in physics, it's called acceleration. That's our definition for acceleration. Okay? And this motion, therefore, because this change in velocity each second is the same each second, because this is a linear graph, this motion is actually called constant acceleration. So whenever you have a straight line velocity time graph, just like this one too, we call it constant acceleration motion. And the slope of our velocity time graph is our acceleration. Okay? The vertical intercept, this lab group got 0.22. So I'm just going to write 0.2 centimeters per second. So this is this number. And I'll cruise over here. This is this number, 0.2. That's ugly. Let me fix that. 0.2 centimeters per second. What is this? Well, this intercept is actually over here, right? Whereas this is the slope. The last number, the vertical intercept, measured in centimeters per second, must be a velocity, right? And since the velocity of our object is changing each second, this is the velocity of this lab group's ball, according to their data, at 0 seconds. Okay? So this is called velocity at 0 seconds. That's the symbol. And you would call it initial velocity. All right? Cool. All right. So you got this symbol that you got in there. All right.